This is the American farmer, the most productive farmer in the world today. His equipment has helped bring him to this position in world agriculture. But more than productivity is engineered into the tools of his profession. Farm equipment engineers design an added safety factor into each machine that comes off their drawing boards. This is the short story of just one such safety device the farm equipment industry offers the farmer to help protect him against injury or death. Tractor upsets, though relatively infrequent, have long been the target of manufacturers' engineering and development efforts. While upsets will occur, injury and death which have resulted in the past can be reduced with the use of a protective frame, much like that of an auto racer's roll bar. It all started here at International Harvester's Farm Equipment Research and Engineering Center at Hinsdale, Illinois. Long before steel was cut and welded, the engineer put the desired design characteristics to paper. The next step was painstaking test and development to laboratory prove the frame's design under simulated stresses. Delicate strain gauges are attached, calibrated, and checked. They will be rechecked again out in the field. Sensitive measuring devices determine how much force the frame will withstand. It will be designed to withstand forces equal to or greater than those a tractor would normally generate in an upset situation. By analyzing the location and type of frame failure and the amount of load that caused the failure, an experimental frame can be designed, eliminating the hit and miss process of many preliminary field tests, which would otherwise be required. In the field, the test tractor will be operated from this remote control board. All normal functions of the tractor, such as starting and stopping the engine, clutching, braking, and steering, are controlled at a safe distance from the tractor to be rolled. At the test site, instrumentation attached to the test tractor by cables connect the strain gauges to recording devices. All systems are now go. The frame will be tested first in a side roll. The embankment is sloped to a stiff 42-degree angle. Tractor speed is set at a predetermined 6 miles per hour. And down she goes. But the frame holds and prevents a rollover. An operator with seatbelt in place would have been shaken up. Nothing more. Despite best efforts, test engineers have difficulty overturning machines. About 20% of the runs had to be aborted when the tractor refused to go down. On this test run, speed of the tractor is increased to 8 miles an hour to generate greater force at impact. The frame is inspected after each upset. Speed is now accelerated to 10 miles per hour, resulting in a severe roll of about 270 degrees. Frame still intact, the engineer calls for one more side roll, this time at a fast 12 miles per hour. Again, no structural failure. But what about a backflip? It has happened. The same instrumentation will be used to record stresses and deflection. The canopy is for protection against the elements. It does not add strength to the frame. For the backflip, they will send the tractor up a 38-degree slope in third gear, throttle wide open. The tremendous shock is absorbed in the deflection of the frame. But inspection shows no structural damage and no intrusion into the area where the operator would have been seated. One final run. The frame takes full load on just one corner. These dynamic upsets prove the reliability of the frame's design and manufacture. Gullies, slopes, hills, and ruts. Common hazards on most farms. Every alert farmer avoids these accident potentials. But should he find himself in an upset situation, his protective frame and his seatbelt could prevent injury, even save his life. He will be within the frame of safety.